Any language?
I don't.
It just knows English languages and stuff.
We can say anything.
So it's
Dolphins have a receptor where they can hear these vibrations.
Okay, so you guys are just making like
a different,
no
like,
hate.
way.
You guys are just making like a lot of a lot of claims, but like.
Well, you're doing the same.
No,
so we really can't come to a
conclusion.
But
I'm backing up my claims, but like I'm just wondering how you guys got to these conclusions.
Yeah, like how
because you're saying you made an assertion, right? I'm not trying to. I'm just curious.
Well, they said the coelacanth was extinct, and we proved that's not true. It's alive.
Okay.
The trilobite was also extinct. We found them.
Where do we find them?
Trilobites.
I know what
they're just not as big as they used to be, but you step on them.
Sure.
I mean, I can show you.
They're not as big as they used to be.
They're in the Paluxy River in Texas. There's dinosaur tracks and human tracks right next to each other, and the human tracks is as big as a dinosaur.
the tracks are still
There are footprints, human footprints from people who were 24 feet tall.
Okay.
So there's all that stuff you haven't looked into, I'm sure.
So there's footprints from people who are 24 feet tall, and I haven't looked into that.
How long?
That's not. Wait.
Let me tell you something else.
Really
Please let me tell you something else.
Okay. Yeah.
Do you know Devil's Tower?
No. Where is it?
Devil's Tower in New Mexico or Arizona or something. It's that E.T. movie was from Devil's Tower. It's actually an ancient tree stump. Look at it, all the mesas that they come up like this and they're cut off. They're ancient tree stumps. Trees used to be huge.
I mean, some trees are still pretty huge.
So that's fascinating to me. Not that big. I've been on the West Coast.
But the reason the trees were
big or 10 times.
The reason the trees were so tall back then, they're not as tall now, is because of things like
higher air pressure and more oxygen.
No, like dinosaurs who would eat the trees, they'd be higher, so they wouldn't be able to absorb the nutrients, so they could survive longer. So that's why they were higher up. That's why now.
But there was higher oxygen
I'm not even talking about, like,
and higher air pressure.
Yeah, no, yeah,
We're ready. Okay, so I'm just curious about how do we come to an agreement about, like, because, like, for example, like your claim about.
I know how to do it.
How do you? So
you go and you look up curvature.
Okay.
And you see that there's no curvature. Then you will say, I guess I better question what I read in the textbooks.
What do you mean by curvature? Do you mean like it being like
so
this?
is just you going out and looking at it enough for you?
Well, we have cameras now that can zoom in 85 miles. So
sure, we have cameras that can zoom into single moons
too. If you look up a P900 moon test, you can see the surface of the moon.
Yeah. And there's no crash craters. They're all just 90 degrees.
You think a camera that can zoom in 85 miles is enough to show curvature on a massive planet?
Yeah. Look up the red boat. The red boat is about how this ocean liner went out, and you can see how it disappears, but the zoom's right back in. But you see it.
Here's my thing. Like, we can't observe just because the Earth is so massive. We can't really observe.
But it's not, sweetheart. This is how massive it is, right there. That takes it right down to the mile.
8 times miles squared.
Squared, yeah. That means the squared part makes it a curve. So if that's a curve, if this is what it is, okay? If it is this, then we will find curvature. You can't find curvature this way.
Well, no, because
if you don't like my formula, then make up your own formula and then go find the curvature.
I'm not saying you're wrong, but I'm just curious. Just speaking super generally, like you can't see. You know, you can't see. Even though you don't see a curve, how do you know there isn't a curve beyond that?
Yeah.
And I'm not saying you know there is. I'm just saying, how do you know, like you're saying from right here and you keep looking there, how do you know it doesn't curve over there?
Well, this is Chicago, across 60 miles of Lake Michigan. We should be looking through the water at Chicago, 1,700 feet down.
Sure, but you know, like the Earth, even though it's flat, you know, it goes pretty deep. Like the ground goes deep.
Yeah, but that has nothing to do with curvature.
Sure, but you know, if you're looking at the water.
Sure, but I mean, like you talk so fast, like you don't hear what I say. You just want to.
I hear what you're saying.
Like, what about this? Like,
I'm not. No, Chris. Like, I'm not even trying to. Like, I'm just wondering. So
you have to do this first before you go anywhere else. You have to do this. And take it one step at a time.
So why are you?
And you are not going to get this today. There's no way you will even comprehend this today. It's a totally new thing, so you have to go find a curvature, get in the car, go down to the shore, and go to Wildwood and look at Atlantic City, 32.6 miles away, and say, holy cow, there's no curvature.
Sure.
And then you'll start.
But ready? Here's the interesting thing, right? If I had, so then, you know, if the Earth is flat, right, I should be able to see from one edge to the other, you know,
okay.
barring any, you know.
Did you drive a car, right?
Yeah.
Did you ever drive in the fog?
Sure.
Okay, how far ahead of you can you see?
Oh, like 5 feet.
Yeah, 5 feet, sometimes not that.
Yeah.
Well, between here and Spain, there's a fog. It's just spread out.
What about from here and I'm looking down to Argentina?
Well, there's land in between there.
So hypothetically, let's say we build, you know, we climb up that tower in Kansas.
But why do you want to buy a tower or climb a tower when you can go to the shore and you got a flat surface to work with?
That's why
sure, but you keep saying sure, but.
No, so you just kind of not letting me talk. I just
sure, but.
So fair enough. You know, you can't see curvature from.
So then there's something to question.
Sure, totally. But how do you know that? And I'm not saying it does, but I'm just saying that, you know, if you're looking from Atlantic City and you can't see any curvature, you can't see that far. So how do you know it doesn't start curving later? I'm not saying it does.
Well, that's why we have the zoom cameras, and you can zoom in. If it's a clear day, you can zoom pretty far.
Sure, but my question is
but.
Right. So my question would be is if we get up on a tall surface with nothing obstructing our view, we should be able to see all the way down to, you know, all the way down.
There's some place called Lookout Mountain, Tennessee, where you can see 7 states.
Sure. Can you see
Antarctica?
Can you see Antarctica?
No.
Why?
Because of the limitations of our eyes.
So we have
because of perspective.
We have that zoom camera. So if we
but there's not one good enough. So and perspective brings it to a vanishing point. A vanishing point or a vanishing line. And it vanishes in that 2 planes coming together, the convergence.
So if
that's the way it works.
Limitations of the eye, then that would make sense that you can't see the curvature right on the ocean when you're looking out.
Yeah, and you do think that ships go over the curve, but that's why you have the zoom in, and it brings them right back. And if they were over the water edge, then you'd have to look through the water to see it. But you don't. You can bring them right back on the surface. See, I mean, this is one point. It's going to take you weeks.
So is this your formula? Is you make this?
No, I think
actually, I think if you go on Earth Curvature Calculator on Google, I think that's the same one.
Sorry, I don't want to make any incorrect assumptions. Do you believe that the Earth is spinning, or
no? No. The Earth is stationary, but the dome turns on top. The dome is the crystalline dome talked about in ancient writings. The stars are fixed in the dome as though somebody nailed them there.
So how do you know that is?
Because there are experiments which prove that. This one, Aries failure, proves that the stars move around us and not the Earth.
How close is the sun? How close is the sun to the Earth?
Okay. Well, I don't know exactly, but I just got a feeling it's like 9.3 miles.
9.3. Okay.
I'm just going to say that. So I'm just going to throw it out there.
Sure. 9.3 miles. Sure. So, do you know about the speed of light?
Yeah.
So you know it's a finite speed, right?
Yeah.
So light travels at speed x. Can I finish?
Yeah.
So right, if light travels at speed x, then if it's light travels at
186,000 miles per second.
You know, awesome. Yeah. So in 1 second, it should cover 186,000 miles.
Yeah. So guess what we're finding out? Some things in physics are not right.
Like what?
Like maybe the speed of light is not right.
If the sun is millions of miles away, like this, like I don't know what this proves, like because there's a spot in the ozone layer. It's probably a hole in the ozone layer at the time.
How do you know there's an ozone layer?
Well, because it protects us from the sun.
Yeah, but how do you know that?
You
don't know that.
9.3 miles away, we'd all be burning alive right now.
Only if it was the sun they tell you about. But if it's just a small, close sun.
So if this.
See, this is the. Wait a minute. Yeah. Is there another sun? This is totally different than what you've been taught.
If you look at the
totally different.
Okay, sure. So
forms of sun.
I'm curious. I've never read these. I will go research these, but.
This is good for a conversation with your buddies who are like educated, that you can figure this out.
So like, if the sun is 9.3 miles away.
I'm just saying a guess, but I like that number.
Yeah, okay. If you say the sun is 9.3 miles away.
You like that? What if I said the sun was 10.3 miles away?
That'd be a whole lot better than 93 million.
Sure. Okay. But how do you know How do we go about figuring out what's right?
I'm just guessing, but I like that for some reason.
So, like, the energy
is that
emitted,
convincing to you though? Is
that
that just because
I know. I think it's possible. Go ahead.
so like the energy emitted from the sun, like just how much energy it gives out, how many joules of energy. When you look at it, obviously, if you look at it directly, it can blind you. If you look at it for too long, you understand? Like,
Do you know anybody who's been blinded by the sun?
no.
Did
but
you
I've
know that there are
temporarily
people
been
who
blinded
do
by it.
sun gazing? They can stare at it for 5 minutes. Now, when you... No, wait, no, sun gazing,
I've
it's a
never-
real thing.
No, sure.
Actually, it helps to open up your mind.
Yeah?
That's what I've been told.
Would you try it
But
out? Just
I
for-
have done it, only you do it at the very low, when it's in the thickness of the atmosphere, you know, and it's orange.
So wait, so if
Yeah.
there's an atmosphere, it wouldn't. There's an atmosphere. Atmosphere.
Atmos, no sphere.
You said atmosphere. Though.
I know, I'm wrong.
So
It's
just,
a force of habit.
so it's just an atmos.
That's what we're supposed to call it. Atmos plane, I don't like, so I just call it Atmos.
So if you're looking, if that was, so then why are like clouds like out there? If it was like this, wouldn't they just be up here? They wouldn't. You wouldn't be able to.
Okay, sure. But,
That's
1 second.
perspective. That is perspective. Look,
Sorry.
these clouds go all the way,
Sorry, just
but
about
you
the,
never see the bottom of the cloud. They never go over the curve. Did you ever know that? On my channel, Maryland Spirit Level, that's my channel, and I made a video about that. You never see the bottom of the cloud.
I just have a question about the dome, right?
Look up lightning sprites.
Sure. Lightning sprites? Okay.
They come off the dome, and on my channel, I have one
But
of those
I just have a
videos.
question about specifically the dome. So humans built the dome, or was it just always a dome?
I don't know who built the dome. I think
Was
a
it built?
creator.
So
A creator, you figure out who that
So
was.
it's been stretched across the
How do you-
entire flat Earth.
No, but right,
entirely, and
how
it's
do
been
you?
built up
What convinced
however
you?
many miles?
What convinced you that?
As far as
there's-
I know, that's
hold
what
on,
we
hold
can see.
on. What convinced you that there was this dome?
Lightning sprites, and stars don't have parallax. Do you know what parallax
Yeah.
is? There's a star at that end and one at this end. But see, if I move over here, now it's over here to the left and here's to the right.
But that's
So
just
parallax, stars
the
never
first
have
step.
parallax.
But that's just from
But
your
then,
perspective.
wait, no. But then, how would if we looked at a road and they converge? What is that? That's parallax.
Look, this is,
Yeah.
no,
Look at that road.
convergence does not mean parallax.
The parallax is how it converges based on your
Perspective.
based
The
on the
stars are fixed. They do not change respective positions. This is what the textbooks teach us. The sun is hurling through space in the Milky Way, which is hurling through space, and the planets are all chasing it, orbiting the sun. That's what they teach us. This is reality.
Okay.
Leave the aperture open, there's Polaris in the middle. So you don't get, that does not give
But
you
you're saying the
this.
stars are stationary. Right?
Yeah.
They are in the dome, fixed in the dome.
They're fixed in the dome.
All of the constellations are fixed,
So they don't
and
move at all.
they move around us like this.
So okay.
And perspective will teach you how they can look like they're going away or closer. It's something you have to study. Study.
Yeah, but don't you think there's people that have studied this for their whole lives that might know, like...
It was really,
More
it's been a really, the psyop is that it was hidden, and it's being covered up. So,
How do you know that?
want to look it up?
Yeah, thank you.
Thank you. You can ask a question. It is being covered up so they can have control
So
and
what
do
about,
whatever
like,
they want.
What about like the landing of the moon?
No, I don't believe in that at all. That was the first thing I looked up. Somebody said, we never landed on
What
the
about
moon.
the
I said,
Mars
what? You're kidding me.
What about like the Mars rover?
So
No.
just that's did you like my example? Can I go back to my example?
I think
with,
that's a little place in Arizona.
Can I go back to my example
Arizona.
with radio towers? You know,
Well, I don't know.
no, just like ready. Just think about it. You know, radio towers. They basically it's a wave, but it travels like in a straight line, right? So
Okay.
radio tower. You know, this is radio tower, and you know I'm walking away from it. So you know, and I'd say I have a really good receiver that receive signals. You know, really from really far distances. So if I should keep walking forward, right, from this radio tower, I should continuously receive its signal, right?
Okay.
So why is it that, I'm not receiving, if I were to set up a receiver for, cell phone signals in China or Europe, I wouldn't receive them here.
Well, because you need a booster, the signal does lose strength.
Okay, but do you agree with me that we have really large, antennas and receivers that are capable of, picking up very minute differences in energy.
This is the curvature formula.
No, I understand.
Go find curvature.
No, I'm just curious.
We can't like prove what you're saying, and I want to prove.
I'm not trying to prove anything. I just have a question. I'm literally just asking you a question.
Yeah, but I can't answer it.
Well, then,
I can't answer it.
No, and it doesn't mean she's wrong. It just.
Thank you.
No, seriously. I mean, just
yeah, it's just like.
Well, like, what about like the properties of water? Like,
but see, that's evidence. That's evidence. So let's say we had a sufficiently, strong receiver, and the Earth is flat. So I should be receiving the signals from China, right? Let's say I can pick up.
Well, you know what? How come do we really know what the government's telling us? If they're going to lie about this, do we really trust everything they say?
Sure, we don't.
They could be getting those signals just fine and telling us, "Oh, we can't get them."
But
so
people build their own radios, right? People can build.
Yeah, hams. Yeah.
So people can, we have private observatories and all that.
Well, I think they're pretty closely monitored.
What do you mean? At least the people observing them should know something.
Well, I think they're controlled, actually. I can't really comment on that.
I'm just curious, what makes you think they're controlled?
Well, I'll tell you why. Because if the government would hide this, if the government would lie about the ground under my feet, they would lie about anything. That's why. Now look at this. I unhook it and then the breeze comes. What is that?
But like the Earth was said to be, round well before the government, right?
No. No. This is about a secret society. This is the secret society. This is not about the formation of the United States. This is well known. This is secret society has been in power for longer than that.
Right, it was the ancient Greeks who said that the Earth is round. That's what they talked about. Who was it? It might have. Oh. So,
Aristophanes?
Yeah, exactly.
Yeah. So, well, we kind of questioned, his thought was that it had to be a sphere. Well, that can happen if the sun is close, too. You get the same results.
The only thing that he was with you because there wasn't evidence that the Earth was round. But his experiment, he noted that in his city, there were no vertical during the summer solstice.
I know, but the same results happen if the sun is close.
No, I'm just talking about the curvature of the Earth.
Yeah, you get the same shadow idea if the sun is close.
So why is it that I go over into China and it's nighttime?
Yeah.
Oh, because the sun can only illuminate a local part at one time.
With all. Okay.
And it goes around. On this here, it goes around. If you get the second, no, the sun moves. The Earth doesn't. Okay.
So the sun moves around these.
Look at this. The second video of this. It's the time lapse of the sun. The time lapse will show you how it goes away smaller, smaller, smaller.
Sure. So
did you know?
I think that's the thing about.
Did you know that the sun moves faster on Capricorn than it does on Cancer? The sun is moving so fast down here.
So that's an interesting thought.
It moves much faster.
Sure. So why is that? Why would the sun? Why would?
Because it has to get around in 24 hours.
No, that's the one thing. Ready?
It changes speed.
The sun changes speed.
Yep.
So ready? I can see the sun here, and I can see the sun here, right?
Yeah.
It's a vertical line.
Yeah.
So how would the sun be moving faster here?
Because it moves. It moves out to the equator, and it moves out to Capricorn.
No, but let's say I'm sorry. What is this?
And
line?
if there's a dome, it's probably lower too.
So sorry. What is this line? Which one is this?
Cancer.
Cancer, and this one is
equator. Capricorn.
So let's say we have two people who are at the same vertical, on the same vertical plane.
Longitude line.
Yeah, exactly. On the same longitude in Capricorn and Cancer. And they can both see the sun. So on that longitude, the sun should be at the same location, right? But if the sun moves around Cancer quicker than it moves around Capricorn, how would that would? It
moves faster in Capricorn than it does in Cancer.
But ready? Like, do you agree with me that a person standing in Florida and a person standing in Argentina can both see the sun at the same time.
Yeah.
So, so the person in Argentina, if he could, if he does the math, he would observe the sun here, right? Or rather, he would observe the sun here, and he would observe the sun, in a different place. How would that work? Like, if two people can see the sun from two different longitudes, how would one longitude
Be moving faster.
like? Why would it be moving? If the sun's orbiting. The sun isn't
The
orbiting.
sun is going around.
Okay.
Okay. Then it goes closer to the equator. Then it's on the equator for the equinox, which we just had. Then it keeps moving closer to Capricorn.
So this is within
Then
the
it's
span of
out
a year,
here.
right?
And then it comes back and to the equator, and you have 1 solar year.
Okay, so that's 1 year. But ready? We're looking at the sun on the same day, right?
Okay.
So let's like freeze time, right? The sun's just suspended right now, and you're standing in.
Well, they're longer days and shorter days.
Okay, sure. You're standing in Capricorn. Sorry,
And
Capricorn?
what do you
I'm
think we
standing in
should
Cancer.
see?
So what I think we should see.
I'm kind of missing what you're saying.
So I'm saying. So you were saying that the sun moves different on the same day. If I'm standing here in Argentina and you're standing, here in Florida.
Oh, no, when it's our winter, it's on this line. This is their
Sure, but
south summer.
Like I said, let's freeze time. If I'm here and someone's on a boat right here, and we look at the sun.
Yeah.
Both of us look at the sun.
Where's the sun?
I don't know. I've never heard this theory. I don't know where the sun is. I'm trying to
Okay.
understand this.
So say the sun's on the equator.
Okay.
Now what?
Yeah.
Why, if this guy looks at it or this guy looks at it, what's the difference?
Is it the time zone?
But let's say the sun is in Cancer. So, the sun should be directly above this guy, right?
Yeah.
But what about the person standing here on the same day?
It's not directly above him. Did you ever notice that when you
if the Earth is flat,
did
right?
you ever notice the sun rises at different places in your front
Sure,
yard
but
and sets in different places? Did you know that the moon crosses the equator 26 times a year?
Did not know that. No.
Yeah, I didn't know that till 2 days ago.
So this is the interesting thing, right? If the Earth is a flat plane, right?
Yeah.
And the sun is above this line.
Okay.
The sun, if the Earth is flat, we should be able to draw a straight line from this point to the sun, right?
Yeah.
So a person standing right here. Let's say, I don't know if this is actually true, but for the sake of argument, if the sun is orbiting around this orbit, and I'm standing here, and I'm at the exact point where the sun is directly above me.
Okay.
There could be a straight 9.3 mile long line to the sun, right?
Okay, and there shouldn't be a shadow. You should not cast a shadow if it's directly above you, right?
Sure.
Right.
Okay, so then what's the question?
So my question is, if the sun's right here and I'm observing it, I would, if I stood just a little bit higher here, I should be observing the sun in a different place, right?
Yeah, it would not be directly above you. It would cast a shadow behind you, and it would be down south. It would be closer out,
So,
south.
sorry, how big is this dome?
Well, if you take the diameter of a
height.
60,000 mile circle.
The height at the...
I don't know what the height is.
The radius, I guess.
We don't know that. Yeah, we don't have a lot of answers. But I do know curvature is where you should start.
Sure. So,
At least he doesn't say but anymore. He's just saying so.
my question is, I think it's a whole thing about perspective, You're in the car and you're driving.
But I
right?
know there's no curvature.
No, I'm not talking about curvature. I'm talking about strictly about perspective, right? You're in the car, and you see everything else moving. Let's say you're just looking out the window, like in a very small
You
point.
see parallax.
No,
in the car?
You're looking out the passenger window. Someone else is driving.
Okay.
And you see trees and poles moving past you.
But something in the distance does not move as fast as what's closer to you.
Sure.
yeah.
Okay. And
That's called parallax.
Okay.
Yeah.
So, my point is, how do you know? This is strictly kind of a philosophical question on perspective. How can you tell that the car isn't actually moving and the world is just moving around the car, rather than you actually moving?
Aries failure can show you what was moving. It was about the starlight. You look at some of these experiments.
So the stars are moving?
And this is an interferometer.
Okay.
And that'll tell you what is moving and what's not.
Sorry, I just gotta run a class. But it was really interesting. Thank you.
Yeah.
Yeah, thank you.
Thank you. Bye. Had a good day. I can't talk though. My voice is gone. Did you get a card? Okay. See ya. Bye, guys. I gotta walk slower or walk more deliberate so I don't get you guys all shook up. I think it was a pretty good day. A lot of activity. And I think we opened up some minds. I don't know what that guy was asking me at the end there. I was like losing patience. Maybe it's me, I got a little tired. Of course, I didn't think he knew what he was asking either. So, this is a beautiful campus though. Bye. What a day. Oh boy, okay, I guess I can shut this off because even though I'm still taping, that's exciting. Alright guys, I'm so happy. This was a good day. Talk to you later. Love you, bye. Get out there and do activism. It's very rewarding.